In this lesson, we're going to be drawing graphs of these transformations of sine and cosine, and we're also going to bring back tangent. So when we're asked to graph a sine or cosine function, there's two pieces of information we might be presented with. We might get a verbal description with period, amplitude, frequency, midline, just different information they might give me, or we might get an actual equation. For tangent, we're always going to be given an equation because really the only identifying feature of tangent that we could give you is period, because it doesn't have an amplitude, midline, max, or min. You can and probably should use your calculator, especially for tangent as a guide when you graph these, or at least if you have an equation at the end, just check to make sure it's right. So here's our first one. I have a verbal description, so I cannot start from the calculator. It says, in the graph to the right, draw at least one complete cycle of a sine graph passing through this point. So when they say at least one, I'm usually just going to draw one. So I'm starting from 0, 2. And the biggest thing about the sine and cosine graphs is to think about the quarter points. So we think of it just like 4 stops along the way. We have an amplitude of 3, a frequency of 1 over pi, which means that my period is the reciprocal of that, so the period equals pi. So what that means in terms of quarter points is this is the full period, so this would be me splitting it into 4 quarters. The midline is 2. The midline is pretty important. For a sine graph, we know it starts on the midline. I'm just going to draw a dotted line here. So sine, we know, starts on the midline, and then it goes up, middle, down, back to the middle. So I need to know the amplitude to know how much to go up from the midline. So I'm going up 3, middle, down 3, middle. And if I connect those points with some sort of curve, that is going to give me a sine curve. So that's one period. I could continue and repeat that. I could go backwards, but that is enough. This is a little off just because I'm drawing on the smartboard, but that does go straight down, or curve down to 0. So the first question we have is state an interval over which the graph is increasing. Now if I extended this, I could make it a little bigger, but this first piece of my graph is a piece where it's increasing. So if I look at what interval that is, what x values, that's from 0 to pi over 4. I could also write that in interval notation from 0 to pi over 4. Just like earlier in the year, I'm not super concerned whether you use parentheses or brackets on increasing or decreasing, or greater than or equal to, or just greater than, less than signs. But I'm going to write it like that for now. Next question says, state an interval over which the average rate of change is 0. So that means if I connect these 2 points on my graph, the slope will be 0. And we know a horizontal line has a slope of 0. So if I connect here to here, and I did the slope formula, that would have a slope of 0. So that interval is from 0 to pi over 2. And here, I just want to say from the one point to the other point, including those points, so I'm going to use equal to, or I could write it like this. Looking at my next one, I have an equation to work from. So I have 4 cosine 3x. This one, it says at least one cycle again. So my first question, I'm going to answer before I graph, because this is going to kind of help me think about the graph. What transformations occurred on the cosine parent function? So that's y equals cosine of x to produce f of x. So my 4 in the front is a vertical stretch of 4. And then my other transformation from 3 is a horizontal compression of 2 pi divided by the b value, so 2 pi over 3. So that's going to help me graph this because that tells me that if I want to graph one period, I'm going to put 2 pi over 3 out here and then split it up into those quarter points. Now, I don't necessarily have to label them. We're actually going to see for letter C if I have to figure them out, but for now I'm just going to put those lines down because it is a little bit of a thing to figure out what numbers go on there. So from here, this is a regular cosine curve. It starts at the maximum. The maximum in this case is 4 because there's no vertical shift, and my amplitude is 4. So I can just kind of put the numbers I need on my graph since I can pick the scale. So for cosine, we go top, middle, bottom, middle, top. That's our shape. And we can sketch it in here. So I see my graph. I could graph it on my calculator. I'm just going to actually do that after I do exercise 3. I'll pull up the calculator, and I see my cosine curve. My next question says, state an interval over which f of x is negative. So this means y is negative. So if I look at my graph, from here to here, y is negative. So I'm actually going to have to figure out those quarter points. So if I split this in half, I get pi over 3. If I split that in half, and maybe I think about degrees, pi over 3 is 60. So this would be pi over 6, which is 30. So I have 30, 60, 90 is pi over 2. Now I could do some fraction work to get those values, but I think that's the easiest way to think about what goes there. It doesn't look like we're counting in any sort of efficient manner here, but if I look at this, I have 1/6, 2/6 is 1/3, 3/6 is 1/2, 4/6 is 2/3. So I am counting by sixths there. So looking at the next one, interval where it's negative. So we do not want it to equal 0, so I'm not going to include those numbers. So the graph is negative between pi over 6 and pi over 2. So looking at our next graph, we're going to graph 5 sine of 1/2 x plus 3 on the interval 0 to 8 pi. So starting out, we need quarter points. My period is 4 pi if I keep flip that 1/2. So 1, 2, 3, 4, 4 pi. I'm just going to stick with that. I do need to continue this to 8 pi, but that is one period. So I'm starting from y equals 3. Sine starts on the midline. This is positive sine, so I'm going up. So at my first quarter point, I need to be up 5, back to the middle, down 5, back to the middle. So here is my sine graph. I need to continue it out to 8 pi. So I'm just going to repeat that process. So I go up, middle, down, middle, and now I graph that over the interval. I have 2 sine curves, 2 sine periods. So next one, we need to graph f of x plus pi on the same interval. So f of x plus pi is a transformation right pi. So I need to take all of the points and move them, and that's incorrect. I don't know why I wrote right. Left pi, right? We have positive, so we're going left. So I need to take all my points and move them left pi. So this one's kind of hard because that's going to go off the graph, so I'm not going to worry about that one. And I do not want to go off the graph because I want the same interval. So left pi, and I can tell this is pi, right? So 2 spaces is pi, left pi, and left. So I'm just moving them all over left. So I'm going to graph in what I have so far. And I have to go one more, just following the pattern, because I want to make sure I go out to 8 pi. So I would definitely label these. So my green graph is f of x plus pi, and my blue graph is just f of x. So I can see which is which. We can see the graph is moved to the left pi.